Hi, it's Mrs. Pope, and today we're going to be talking about factoring polynomials. When we talk about this type of factoring, we want to find the GCF, the greatest common factor. So our goal today is to find the greatest common factor, GCF, of a polynomial, and we want to factor it out. So when we have a polynomial here, we want to see what these two, the greatest factor that they have in common. They may have many factors in common, but we want to find the greatest factor that they have in common. Factor that out, or kind of divide that out, so you're just left with the remainder. So let's see what that means. First thing you want to do when it says factor, and you see there's no equal sign, we just have an expression. So we're just trying to get the GCF, get the greatest common factors out of there. So you want to look at the coefficients, the numbers next to the variables, and also the variables. So first, let's look at the coefficients. We have 12 and 36. Well, let's see, what are our factors of 12? And I'm not going to do this every time, but this will show you how you can figure out the greatest common factor. If you think of your factors of 12, you could list them. 1, 2, 3, 4, 6. These are all things that you could multiply and get 12, and 12. So 36, if you listed the factors of 36, you'd have 1, 2, 3, 4, 6, 9, 12, 36. Hopefully I didn't miss any. If I did, let me know. So like I said, they have many factors in common, but we want the greatest common factor. So the greatest that they have in common, if you see here, would be 12. So 12 is the greatest common factor between 12 and 36. So our GCF, as far as coefficients are concerned, is 12. And now we have to look at the variables. We have two a's here, because this is a times a, and we have one a here. Remember, a squared is nothing more than a times a. So what's the greatest that they both have in common? They both have 1, but then the other one has 2, so they don't have 2 in common. The greatest that they both have would be 1. So our GCF would actually be 12a. Once you find your GCF, you're going to write that on the outside of the parentheses, and you're going to see what do you need to multiply to get back to the original expression. So I already have, this should say 12a. I already have 12a. So I need to get back to 12a squared. So what do I have to multiply 12a by to get 12a squared? Well, I'm missing one of those a's. And then what do I have to multiply 12a by to get 36a? Well, I need to multiply 12 by 3 to get 36, and I already have the a. So this would be the factored form. You can always check and see if you're right. There's no way to not know you're right. You can always check it. Distribute, and you should end up with the original expression that you have. 12a times a is 12a squared. 12a times 3 is 36a. Is that exactly what you had in the beginning? Yes, it is. So you know that you factored it correctly. All right, let's look at another example or two. All right, example 3 and example 4. Start with example 3. Factor 3x squared minus 12. Let's find the GCF. Well, looking at our coefficients, the greatest common factor in 3 and 12 has to be 3. So our GCF would be 3 as far as the coefficient. This has x squared that doesn't have an x, doesn't have x squared or anything. So there's nothing else that these two have in common. So 3 is your GCF. So we take a 3 on the outside, and what do you have to multiply 3 by to get back to 3x squared? That would be x squared. Minus, what do you have to multiply 3 by to get back to 12? Of course, that would be 4. You can always check your work. 3 times x squared, 3x squared. 3 minus 3 times 4, minus 12. These two are exactly the same. You know that you did it correctly. Okay, let's look at a longer one, example 4. Example 4, we want to factor a trinomial. There are 3 different terms here. So we need to find the GCF between all 3 of these. So if we're looking at the numbers here, we're not just looking at 18 and 24. We have to look at 18, 24, and 36. So let's look at the GCF. What would the GCF between 18, 24, and 36? Give yourself a second if you want to think about it before I go on. The factor here I'm thinking is 6. 6 goes into 18, 6 goes into 24, 6 goes into 36. You can verify that on your own, but the GCF as far as the coefficient is going to be 6. But now let's look at our variables. We have x squared, we have x, and there's no x's in the third term, so x is not even an option. Y squared, and y squared. Great, so the most that they have in common is y squared because all three terms have y squared in them. So our GCF here, our greatest common factor, is actually 6y squared. So with 6y squared, if we take that on the outside of the parentheses, we're going to divide it out of here or ask ourselves, what do you have to multiply 6y squared by to get back to this first term? Well, 6 times 3 would give me back to 18. I don't even have an x squared, so I need an x squared here. Y squared, it's already there, don't need it. 6 times what would give you 24? Of course, that's 4. I need an x because there's no x on the outside, and I already have the y squared. 6 times what would give me 36? Of course, that would be 6, and the y squared is already here. So this is in fact factored. I've taken out the greatest common factor. Try to check this on your own and prove to yourself that you got the original expression.